Hello and welcome to this webinar about machine learning, data cubes, territorial planning, and a whole lot of other stuff. It's one of the webinars in the INSPIRE hackathons. Actually, two of the INSPIRE hackathons are going on right now. It's the Dubrovnik INSPIRE hackathon and it's the Kampala INSPIRE hackathon. My name is Bente Lilja Bye. I'm going to be your host today, and with me I have a panel of speakers. And before I will let them introduce themselves, we will do my signature of the webinars, namely to do a weather report so that people can come into the room and enjoy the presentations. So I will start with you, Jan. Can you give us a weather report from where you are and tell us where you are?
Hey, my name is Jan Chytry. I'm in Brno, which is the second biggest city of the Czech Republic. And now I think it's 7 degrees, but where I live, I think it's much colder because we are uphill. So it's like really cold.
Very detailed. Thank you, Jan. How about you, Hanka? How is the weather and where are you?
Hello everyone, I am Hana Kubickova and I am based in Litohlavy, which is a small village next to Pilsen. And currently the temperature is not that high, it's 5 degrees Celsius, but it's beautiful sunny weather.
Sounds lovely. How about you, Peter? Where are you and what's the weather like?
Yeah, hi. So weather is the same here. We have big sunshine here, but don't get fooled about that. Just like in Czechia, it's pretty cold. So we have single-digit temperatures here. And by the way, what you just heard, Pilsen, the Czech guys, they have the best beer in Europe. So if you ever get the opportunity, go there, try it.
Oh, I definitely will agree with you. And that coming from a German, you didn't say where you were, Peter. Where are you situated?
I'm sorry. So I'm in Germany, actually sitting in Bremen in the north of Germany, close to the North Sea. It's approximately like London. So I just would have to follow horizontally going west and I would end up in London. And there's just a little bit of swimming in between.
Yeah, just a little bit, yes. And people actually do that. So yeah, I think we started very well with this webinar because a German gave a Czech a compliment on the beer. That's huge. That's huge. I know. So in my weather report, I'm actually way up north. I'm beyond the Arctic Circle, close to Saltstraumen. It's the world's strongest maelstrom, just close to Bodø, one of the hub cities there. And we have today a beautiful weather, as opposed to yesterday where we had storm and snow and everything. But here today, beautiful. Now you have listened. Thank you for your attention to this weather report. I see that there are many on here. Welcome to all of you attending. And now it's your turn to give us your weather report. You can use the chat box and tell us where you are situated, where you're from, and what the weather is like. And the same chat box is where we want you to ask questions. We really want to hear your questions, and you can use the opportunity today. And if you have any comments also, those are more than welcome. So please use the chat box. Start with giving us a weather report. So with that, I think we are ready to start. The program is that we have 3 presentations and then we have a Q&A at the end. I will also recommend that you ask some questions that we can do in between. But the main discussion, the main question and answers will be at the end. So don't worry if you are too slow in writing the question in between, immediately after a presentation. We will have time to discuss it at the end of the webinar. We assume that the webinar will take about 45 to 60 minutes. That's what we expect this webinar to last. What else? You will get a replay since you're registered. You will get a replay of the webinar directly in your inbox. You will also get a copy of the presentation. So have that in mind when you're listening to this webinar. With that, I think we are ready to start. I will do the presentation of all the speakers now, and then we will start the program with Hanka introducing machine learning from applied on agriculture, and she will also introduce some of the challenges that you can benefit from participating in a virtual hackathon. We are doing an all virtual hackathon now, 2 of them. And then Jan will present a territorial example. And then last but not least, Peter will introduce us to DataCube. All of them will also introduce some of the tools that they are using. So that's the program for today. And now we will do the tour de table with the presenters before we give the floor to Hanka. So Jan, I will start with you. Can you introduce yourself and tell people who you are and what you do?
Yeah, so hello to all. My name is Jan Chytry. I'm an undergraduate at Masaryk University in Brno, Czech Republic. I would like to welcome you to this webinar. I will talk to you about the potential of satellite image classification for food security, mostly classification of land cover or land use.
Excellent. And then Hanka, can you introduce yourself?
Sure. Hello and welcome, everyone. I am Hana Kubickova. Last year, I graduated in geomatics at the Faculty of Applied Sciences at the University of West Bohemia in Pilsen. Currently, I'm employed as a project management support at Plan for All, and I also conduct research related to artificial intelligence and its use in precision agriculture. And today I will tell you more about field boundaries detection using deep learning and artificial intelligence.
Exciting. And Peter, how about you?
So that's myself. Hi, Peter. And I'm actually a computer scientist specializing in the field of databases. At some time, we have started doing big, massive data cubes, as it's called today. In my field, it's called array databases. So call it actionable data cubes. That has led, on the one hand, to technology that we have developed, proving that this really can fly. And today, more and more research groups worldwide are jumping on that topic. And that has also led me into standardization. And so today I'm the writer of the DataCube standards in the Open Geospatial Consortium and also in ISO.
Excellent. And well, a little bit about me as well. I'm not only the host of these webinars, I'm presenting here Plan for All, and also a project called EO for Agri, and another project called NextGeos. And they are all about Earth observation and using Earth observation. And that is my background for a couple of decades now. I've been working on the use of Earth observations and data management, data being Earth observations. My initial education was theoretical astrophysics, but you know, I don't discriminate against any of the planets. So with that, before we start, just a clarification. The word that we use Earth observation. So a lot of this data is Copernicus data, Earth observation. Make note that Earth observation means actually not only satellite-based observations, it also means in situ or ground-based observations and anything in between. So it's all sorts of measurements and monitoring of our planet. Just make note of that. Okay, so now Hanka, I think we are ready for you to start your presentation. Go ahead, the floor is yours.
Okay, thank you.
Yes, we will, our videos will disappear, but I promise we will come back to you after Hanka's presentation.
So can everybody see my screen right now?
Yes, and Peter, can you also turn off your camera? Wonderful, thank you. Go ahead, Hanka.
Thank you. Hello and welcome, everyone. For those who connected to this webinar a bit later, I am Hana Kubickova, and I am going to tell you some background of deep learning techniques for boundaries detection. I'm going to present a work of three of us, me, Jan Horák, and Ondřej Kás. So first of all, let me briefly describe you what is the motivation for field boundary detection. This motivation actually lies in the fact that if we have available the accurate information on field boundaries, which means its spatial extent and location, then we have a valuable input for agricultural applications like crop monitoring, yield prediction, food security, crop management, or many more applications. The thing is that agricultural statistics are commonly calculated per field, and given results are negatively affected by inaccurate or not updated field boundaries. So I guess that the reason why such a great emphasis is placed on precise delimitation of field boundaries is quite obvious right now. So one possible way how to automate the process of field boundaries detection is to exploit the potential of satellite imagery, which provide a wealth of information about Earth's surface and are available as open data. On the other hand, we've got machine learning algorithms and artificial neural networks. So our main goal is therefore to find possible machine learning algorithms or artificial neural networks that can be used for field boundaries detection from Sentinel-2 or Landsat images. Now, let's talk a bit about field boundaries detection techniques. There have been explored a number of machine learning techniques to identify field boundaries. The most commonly used technique is supervised classification, which includes, for example, support vector machine or random forest. Field boundary delineation methods can be further categorized into edge-based and region-based techniques. Edge-based methods focus on detecting the edges in images that are used as a candidate pixel for region boundaries. There is a range of edge detectors from simple algorithms such as Sobel or SHAR to more complex techniques such as Kenny operator. These algorithms divide pixels into edges and non-edges. However, boundaries between objects are not always well defined, which can lead to gaps in boundaries. The third group includes region-based methods that groups pixels into object-based or based on some homogeneity criterion. And the last one is so-called group hybrid methods, which can include, for example, or we can mention, for example, the combination of Kenny edge detection and watershed segmentation. There are, of course, plenty of other algorithms, and I don't want to say that they are not efficient enough, but the current emphasis is put on deep neural networks, which is an artificial neural network with multiple layers between input layers and output layers. The most commonly are used convolutional neural networks, which are applied for analyzing images and have become very popular to tackle remote sensing problems such as road extraction, cloud detection, crop identification, and also for our boundary detection. While using deep neural networks, we have to deal with some remote sensing specifics. The first one is that a very large amount of training data is needed for training deep neural networks. The second one is that computer vision archives, like, for example, ImageNet, cannot be used in remote sensing due to different spatial resolution, a much higher number of spectral bands that satellite data provides, and different semantic content, which is obvious from the images that you can see on this slide. As I've already mentioned, a very large amount of training data is needed when you want to use supervised model like convolutional neural network. The possible way how to deal with this problem is using augmentation techniques that increase the number of training data in your data set by modification of existing data. You can, for example, apply transformation, deformation, or shift the color spectrum on your data. But please note that the number of training data will affect the effectiveness of the pre-trained model very rapidly. Now we can move to challenges that are connected to satellite data. There are many operations that need to be done before you move to training your model. You need to make atmospheric corrections, decide what satellite bands you want to use for training the data set. So when it comes, for example, to Sentinel-2 data, and you decide to combine shortwave infrared band with near infrared band, which have different resolution, you have to upscale or downscale bands using some resampling methods. Then you need to create a cloud mask and ignore the parts which are covered by clouds. And also, you need to crop the area of interest. Now I want to show you what has been done by our artificial intelligence group so far. For the test, we chose the South Moravian region, where agricultural land is around 3,600 kilometers square large, and there are grown many types of crops. So the boundaries between the fields are really good, recognizable. To make the process for the proof of concept easier, we decided to use orthophoto instead of satellite images. This is because of already mentioned challenges connected to satellite data, and it was really the proof of concept only. Besides orthophoto, we used land parcel identification system, which is shortly called LPIS, and downloaded reference boundaries in SVG file, which are also very necessary for training the model. In order to detect the boundaries of individual agricultural fields, it's necessary to first identify the individual fields. For this purpose, we chose semantic segmentation, which assigns individual object to classes at pixel level. Semantic segmentation was performed using the convolutional neural network called UNet. And although the region was completely covered with orthophoto images, the resulting training set contained only a few hundred of tiles. So we used gentle augmentation, and this set has been reasonably expanded to avoid overlearning the model. The images that contained a small percentage of the coverage were then removed from this data set, and this created a training set of 3,400 of tiles, and this set was used to train the network. The results of the previous test shows the accuracy of 92% when it comes to intersection over union coefficient. So this is our work, which was done so far, and there is a space for further improvements and ideas. We can, for example, use different classes. We can use different combination of bands of satellite images, use multitemporal satellite images, and replace the UNet convolutional neural network with mask RCNN and do instant segmentation to obtain more different classes. So this is the excellent opportunity to test these improvements and further ideas in Dubrovnik INSPIRE hackathon. This goes to challenge 2. So I will be very glad if you join our group and help us and share with us your ideas. And this is all from me, and I will be very glad if you ask me some questions, if you have some. So thank you very much for your attention.
Thank you so much, Hanka. Absolutely wonderful and very clear. And we do have, in fact, a question that we can take right away, I think, as Mark, who asked, what resolution was the orthophoto that was used, that you showed?
It was 10-meter resolution per pixel.
Exactly. And a question from me before we go to Jan. The point here that you are using Copernicus data, right? The Sentinel data.
Yes.
Yeah.
Currently, we are using orthophoto, but we want to move to Sentinel-2 data and try this experiment on Sentinel-2 data using different bands, RGB plus near infrared or something like that. Right.
And so orthophoto is sort of something in between ground truth, right? Because orthophoto is photos taken by airplane, right?
Yes, right.
Yeah, but then you can also you can even augment it or use data from the ground as training material, training data as well. Is that correct?
Yes, actually we need to have some reference boundaries. So this is what needs to be measured or obtained from some source, and we used for this experiment land parcel identification system. Yeah.
Okay,
so
great.
This is it.
So, by the way, to the audience, to the attendees, thank you so much for your comments, for your weather reports, and I see that we are people from basically around the world here. We are from Nepal, several countries in Africa, Cameroon, Uganda, Kenya, and Belgium here, Romania. China. I mean, I've seen so many different countries. So thank you for showing up here with us in this webinar. Now, and we have some more questions from you. I'll take a couple more and then I will save the rest so that we can take that at the end. Okay, so the next one is Rahul Raj. He would like to, I would suggest using harmonized Landsat Sentinel data. Yes, that's another data set. That was a comment. That was not a question.
Yes. Okay. You can join our challenge too in Dubrovnik, and we can try.
Yes, absolutely. Yes. Can we do this very quickly now? Let's see. How resource intensive was the training and classification process?
Sorry, I didn't understand the question.
How resource intensive? So how much resources was needed when you did the training and classification process? I think resources in terms of computing.
Time, how time consuming?
I'm not sure how resource intensive. I'm not quite sure. So Elias, can you rephrase your question? And then I will mark all these questions as, and you can do it as yourselves as well.
Okay, I can go through that.
Yes, you can go through it later, because now I think we are ready to go with you, Jan. Are you ready? Because we will take these questions towards the end, I promise. Jan,
I am ready.
Yeah.
All right, my turn. So, so for those who've not been here, my name is Jan Chytry. I'm an undergraduate at Masaryk University in Brno, Czech Republic. Would like to show you some information about satellite image classification, just like a basic theory, and its potential for food security in a way that I'm going to show you shortly. So, image classification is nowadays an immensely practiced set of methods to process Earth observation data in order to extract thematic information. Its overall objective is to recognize surfaces or objects and differentiate between them. Looking at this generic processing chain, we can see there is a path to go before we are able to approach the classification stage. It consists of obtaining satellite data, performing some corrections like atmospheric or geometric. On the image, you can see a geometric correction, cloud masking, and also constructing some derivate Earth observation products that can help us with the latter classification process. Image classification is at its very basis literally about the semantic properties of the surface that we are looking at. So there is a way of something called spectral pattern recognition, which means analyzing pixel character throughout different satellite bands and beyond. And there is spatial pattern recognition that that takes spatial context such as pixel neighborhood or image texture into account. The former view is utilized in classification referred to as pixel-based, while the latter one in classification called object-based. However, aspects of both are often mixed. Let's now assume we have pre-processed our data in some way. Now it's really not important how we've done that. It can be a single image or even a set of satellite images. We can decide for unsupervised classification, or what I want to show you, a supervised classification, where we make use of a predefined training data set of surfaces we want to recognize. So we have some background information about the surfaces we want to recognize. Further phases are then choosing the right classifier and setting it up towards accurate results. This sort of classification is a starting point for extracting land cover and even land use information. I believe we've heard of these phenomena, which are often semantically mixed on a data level. Land cover is an abstraction of what we see directly on the surface, while land use more of a human utilization of that surface. So this is something what we see on these two figures. To the left, there is a land use. I have some sample categories, residential urban fabric and relaxed spaces in green, which is of course very high level information about the space. While to the right, there is land cover setup of, well, this is actually urban area, so land cover doesn't really consist of many categories. In urban areas, you see there are two categories, urban areas and roads. Actually, these two visualizations were gotten from Czech cadastre of real estate. Of course, both land cover and land use datasets are vital for agriculture policies, landscape management, and spatial planning, which are, among others, basic pillars for food security. It is also noteworthy saying that for most but not all land use classes, spatial pattern classification also applies, because it's an essential input thanks to its ability to give it high-level semantics. Here, I'd like to get to my research, in which I'm working on enhancing initially a pan-European land use and land cover database called Open Land Use with products of satellite data. So you can see that how it looks to the left. I can then put the link to the show notes. See, there are also full-pack commercial solutions that perform image classification. However, they often do not offer means to create an automatic processing chain. So these are, for example, PCI Geomatica, Envy, ArcGIS, or Terset. But then there are also open source solutions, which are those that we can automate. They are code-based. We can do some processing chain, and we can execute it one by one to our objective. So this is where I tweaked a very flexible code-based open source alternative called EOLearn, which is a Python library that offers targeting area of interest, easy obtaining and pre-processing the data, and performing classification, which is multi-temporal. So it consists of using more images at once. It also enables me to use derived products like vegetation indices or wetness indices in order to enhance the classification results. In the classification phase itself, it acts like a bridge between the world of Earth observation and computer science, because it lets you choose among various classifiers, including machine learning algorithms. So what I did was using the EOLearn pipeline with Sentinel-2 data. So these are the data from Copernicus in an area to the south of the Czech Republic. So it's actually the same region where Hanka operated in the previous presentation. So as a training data, I used data from the Czech Cadastre of Real Estate, which contain the information about land cover or land use on which I could train. I performed a multi-temporal classification. This is also how I actually pre-process the area. So these you can see on the map of the region that I chose patches on which I performed the classification. I downloaded the data easily from Sentinel Hub, but you can also feed the library manually, but this was much easier. And then finally, so I performed the classification on the set of images from March till November 2019 and used the machine learning classifier LightGBM, which is a very fast tree-based algorithm that nevertheless needs loads of training data. I supported the decision process with some derived products, which also are possible to be created in EOLearn, which was NDVI index, NDBI index, which is a build area index, and also NDWI, which is a wetness index. The overall accuracy of my results was always over or above 85%, mostly around 90%, for which I had 8 land use and land cover classes. You can see this here on the map. This is like a whole patch or set of patches I classified, and to the right there is a detailed and also a confusion metrics and classes I used as an input. So if I was to conclude, of course, systematic research and fine-tuning of the proposed solution, so that means the EOLearn pipeline, is further necessary to really put the results into practice. So to create land use or land cover data set of, for example, an area which lacks these data sets, or an area where these products are just not as fine-scaled as we can obtain from the Sentinel data, which is, by the way, 10 meters in precision. But on my proof of concept, you can see there yet exists a powerful and flexible option to derive satellite image data quite quickly. And these are the data that can support the food security. This is an opportunity also to experiment with this pipeline in Kampala or Dubrovnik INSPIRE hackathons. Okay, this is all from my side, and thank you. And I'm looking forward for questions.
Thank you so much, Jan. Very clear and informative. And I have also to say a big thank you to the audience here they are asking questions and commenting all the time here, and that's absolutely fabulous. And some of the questions are to you, Jan, but I think when looking at the time here and at this particular moment, I think it's important that we get to hear from Peter as well. So we collect all the questions, we see all the questions and your comments, and we take that after Peter has given his presentation, because there are so many wonderful things going on in the chat. I'm very inspired by it, actually. So we will come back to you. I promise we come back to you. But Peter, in order for everybody to have all the information collectively, then we can have a bigger discussion at the end. Okay, Jan? It's okay with you?
Yeah, sure.
Yeah. So Peter, I think we are ready for the data cubes, and thank you all again for being so active. Yes, the as you have registered, you will get the recording. I think I said it 6 hours after the event, so you will get it shortly.
Yes, Bente, indeed. It's really lively in the chat, and I've skimmed over that. It will be an interesting discussion afterwards. Looking forward to that. Okay, so thanks for switching to my slides. And what I'm going to present you indeed is about data cubes that we have brought from research into practice. And let's go to the next slide. And that shows us actually the bad situation we have today. We have big archive.
Peter,
yes.
Can I ask you to turn off your camera?
Ah, okay. Yes, right. It's a bandwidth issue. Good. Okay. So actually, we know about all these many files. We can access them, no problem. It's just that they are in strange format. They are in some sizings that are not exactly good for us to keep, like 100 gigabyte per file if we just want to have something small. Metadata inside the file, in another file, in the file name encoded, etc. And this is why effectively it's not used as much as it could be. But hey, we all know how to do better. We know about seamless maps. And suddenly we don't have millions of single files and objects, but we have one object, the Earth. And everybody enjoys zooming and panning over it. This concept we simply have extended, next slide please, into further dimensions. So we do not just homogenize in X and Y, but we also homogenize in height and depth, and in particular a long time. And actually, analysis of long time series is the killer application today. So why is such a thing good? Well, it allows you to move seamlessly through space and time without thinking of file boundaries, which makes it so much easier for you and for your tools alike. And this thing that we call data cube actually is not just three-dimensional, but actually multidimensional. So we can use the same concept for two-dimensional images, for three-dimensional image time series, for four-dimensional climate data sets, and suddenly the world gets so much easier. That is the effect of the standards that we have. We can utilize them in manifold ways. And on the next slide, we see that actually there is some work behind the scenes. Who has done that homogenization work before? Well, the users, or you, for example. Now, this is being pushed back into the data centers to the data providers, which makes sense. Hey, they have more resources, and why not do it once and for all? So all these different raster data or data cubes get homogenized and then offered via a common concept so that you can visualize them, can mix with other data, or you can even have to have automatic machine-to-machine processing. This is the work that is being done for you now behind the curtain. On the next slide, then, we see our approach to this and this funny name, Rasterman, which actually comes from Raster Data Manager. And the idea is simple. We like the power of SQL. It allows you any query, anytime. It's just that standard SQL did not support data cubes. And this is one reason why SQL has been used in business, but not so much for science and engineering data, except maybe for metadata. So we have married data cubes into SQL, and actually SQL liked that so much that this now has become part of the SQL standard. So yes, from now on, SQL does know data cubes. Okay, with this, without knowing it, way back in the 90s, we have pioneered actionable data cubes, and we have underpinned this concept with a massively scalable analytics engine for big data cubes. Big means that we have data assets of 2.5, actually meantime more than 10 petabyte databases are around. We have parallelized in Amazon, and we are doing planetary scale federation of data centers. This, as I mentioned, has become a blueprint for standards, and so naturally we also are data cube reference implementation. On this map, you see actually our visitors. So Rasterman meantime is well known in the community. The next slide, please. I could talk about technology now, hours and hours, but I don't want to bore you. So just in a nutshell, we have a full stack implementation with Rasterman that actually has every single component optimized for large arrays. So it's not just an add-on to something existing. And as we know the language, we can analyze that and see, for example, with this query here, the yellow part we can answer immediately because we have the data. Not so the orange part. But hey, we have a friend in the cloud that actually has the data. So we cut out this query and send this subquery to the other node that does it in parallel and gets us the result. This is how we do cloud parallelization, and we have done that in Amazon over more than 1,000 cloud nodes. At some time, we discovered that we can do the same thing across data centers. So the blue query part we would ship to another data center, compute it there, and the result comes back. So our guy here sending queries doesn't even need to know where the data sit. In some experiment, in some project with the European Space Agency, actually, we have installed Rasterman on board a satellite, making it a data cube engine. On the next slide, we see a screenshot of how we have done that. So we send a query and we see its path. In that case, EGU in Vienna has been sent to ECMWF in London or close to London. And ECMWF in turn had to send a subquery to Canberra in Australia, the National Computational Infrastructure there, to produce the heavy rainfall risk areas that we see in NASA Worldwind on the top image. You could also send the query directly to Canberra, but it wouldn't help you. They now, in turn, they have to ask back with ECMWF. So you see how they orchestrate dynamically, and you don't need to know where the data sit, and you can do distributed data fusion here. Let's go ahead with the next slide, where we look briefly at the standards. The web coverage service actually allows you to retrieve from such data cubes with such requests, which you simply can type into your browser, or you can construct it from Python. So the first request would get you the full coverage. You identify it with a coverage ID. If you want to do subsetting, you just do the subset definition for each axis. So in the second example, for longitude, latitude, and for time. In this case, you would reduce in latitude and longitude, giving you a trim, as it's called in standardization terminology, and a slice along time. So effectively, from a three-dimensional data cube, you accept a two-dimensional time slice this way. Okay, if you want to have a particular format for your result, then say so, indicate that in addition. And that is the WCS core. So the simplest thing about web coverage service, give me a coverage or a subset thereof, and give it to me in my favorite format. And values are guaranteed unchanged, so not modified into colors, like, for example, with a web map service. Okay, but one thing is very dear to me with the next slide, where we go into a component of WCS that is called, now we have yet another abbreviation, Web Coverage Processing Service. That is actually about space-time data cubes now and processing them, because that's Web Coverage Processing Service. It knows about the semantics of space and time. So as before, you can do cutouts in lot, long, and time. It knows about regular and irregular grids, for example. And just to give you a flavor of it, here is such a query that you would send to the server and execute it there. So let's say we want to inspect 3 MODIS scenes, M1 to 3. Then we bind a variable $C to it that iterates over it. And then we compute the difference between red and near infrared. That is the formula we provide. And the result should be encoded in TIFF. So we would get back 3 TIFF images. But maybe we are only interested in images with some particular properties. So we would do some filtering in the where clause, where we provide some whatever predicate that looks into the data, like only 30% cloud coverage, or near infrared exceeds a threshold somewhere, like here, whatever. So once again, you send a string and you get back a processed result, ready-made for you. Let's proceed. And on the next slide, I would hasten to say Well, I've emphasized so much query languages, and yes, I'm enthusiastic about its power, but you don't have to learn that necessarily. Rather, via the open standards interfaces, actually, you can bring your favorite client, and that can be map navigation simply, like Open Layers and Leaflet. You can use virtual globes. You saw an example of NASA Worldwind, WebGIS, or even analytics with Python or R. So you see a kaleidoscope here of many different portals and front ends that have been built using Rasterman, and they're all individual. You don't need to always see data cubes. Okay, let's move on. So actually, this is where I want to bring you a few links, a few URLs. So standards.rasterman.com is a website that we have been maintaining for quite some time now. It actually illustrates the use of the standards. Inspire.rasterman.com is a website that specifically illustrates how to use data cubes in the INSPIRE context, INSPIRE being the European legal framework towards a unified common spatial data infrastructure. So both of them are just links. They have many examples where you just can click and see the results, and you can study how to build such things. You want to have some more background, then go to Earth Server, where you find lots of webinars, tutorials, etc. And of course, at the bottom, you see my email address. So if you want to use that now in the hackathon, then be my guest, contact me on questions. But for now, have fun. And I enjoy being part of that truly intercontinental community here. And I'm more than ready to answer any question you may have. Thank you, and giving back to the moderators.
Thank you so much, Peter. Very, very exciting that you introduced, first of all, this powerful tool, and that you are available for the hackers in both of these hackathons. This is really great. I see now that we can start to answer all the questions, and you can keep on asking them. I did send you some links in the chat with more information about the challenge that Hanka was mentioning. I also mentioned that we had two challenges related to open land use, as you mentioned, Jan. And then, of course, the data cube is relevant for many different other challenges. So I will give you more of the links as we are, continuing this dialogue. So keep a watch on the chat box. And I will do that when we are doing also the Q&A. So I have noted the questions here. Let me see. I will go through. See how many. Yes, we can start with you. I start from the where we left off. So Anna Maria is asking, what was the size of the bearable grids patches? I think that is for you, Hanka.
The size was 512 pixel.
512
of the patch, yeah, of the patch.
Okay, Mark, what was resolution? We have already answered. Maximilian, what was the amount of patches for the training of the CNN?
Yes, it was 3,400, around 3,400 tiles or patches for training the data set or training the network, but it could be definitely better to have more of them.
Right. So, and Mark comes again. What is the source of the orthophoto that you were using?
Yeah, this was downloaded from our national geoportal called Český úřad zeměměřický a katastrální. This is in Czech. And,
you don't say.
Yeah, I can send you a link.
Yes. Yes, you can paste the link in the chat box. And here's a suggestion. We already took that one using Landsat, of course. The more the merrier of data resources. And then Elias, maybe I will see your precision of the question related to resources later. What is the software you used in this research? I think that's still Hanka.
Yeah, we used we have used Jupyter Hub, and this runs not directly on our computer, but this is on distance server, which is a little bit more effective. And if it goes to tools that we have used, it was TensorFlow, Keras, and Scikit-tool, which are open source neural networks libraries.
Right. So all these things, all these details, I assume will be made available on the workspace of the challenge.
True.
Yes. So just so you know that if there's a lot of information coming in now, if you want to join this challenge, all of these informations will be available in the workspace. Which software did you use for ANN? Maybe that's CNN. I'm not sure.
This is what we've actually answered.
Yes, already.
Yeah, and I've got one more thing I want to add. That for those who want to join our challenge 2, and many other artificial intelligence challenges that we have in our hackathons, there is the opportunity to create users accounts for Jupyter Hub and try to experiment yourself.
Right. And I think, well, we know of several resources to get, introduced to some of these tools. And so I think this will be made available through the workspace there. And the different links to resources. Is Python your primary scripting language?
Yes.
Yes.
For you, both of you, Jan and Hanka. Would you consider, Shivam, would you consider using existing classifiers and extend it further with more open data?
Sure, if there is the opportunity to extend our solution, we will definitely do this. So we are open to every possibilities.
Yes. Is it possible in Google Earth Engine? I think I saw somebody answer that. Is it possible in Google Earth Engine too? I'm not quite sure if Manish, if this question is, does it make any sense to you?
It's for Jan, maybe.
I think it should be for me.
Yeah.
I've not personally tried it. There should be actually for the research I'm doing, there are 2 layers, which one of them should be actually using the open land use also on the commercial level. So the solution I had to use for image classification and the whole pipeline had to be open source. Google Earth Engine, I think, doesn't allow to be implemented in commercial products, or at least partly commercial products.
Right.
So I think it's possible, like technically, but I've not done it personally from these reasons.
Okay, thank you. So Maximilian, he is recommending that it would be interesting if each speaker gives a recommendation, a review paper concerning their project. And I think this information will be available on the workspace of each of the challenges. And I guess that, the recording, again, the recording of this webinar will be sent to you automatically, actually, in your inbox to the email that you used for registration here. But we are also planning to publish the replay and with the presentations on planforall.eu, so you can see if there's more resources that we include in that. So thank you for the tip, Maximilian. Maximilian continues, you are both using optical data. What about SAR data for land use classification to avoid presence of clouds on some areas? I have a comment on that, but go ahead, you, Hanka and Jan.
So yeah, well, we decided to start our work with Sentinel-2 data, and SAR is available, I think, on Sentinel-1. So yeah, this can be done as well, and we can extend our solution. But yeah, we wanted to start with RGB and the bands that provides a Sentinel-1, Sentinel-2, sorry.
Yes. Jan, do you have any comments to this?
Yeah, similarly from my side, as I'm an undergraduate, I've still not had that much experience with SAR data. For my application, it is also possible because once you try downloading the data from the platform, from the Sentinel Hub platform, which I showed in my presentation, I think it's possible to include Sentinel-1 data. Of course, the processing is much more complicated, and it's very different from optical data.
Yes, indeed. And I have heard about this. This is a very interesting suggestion and a problem that I believe several is now addressing. We in the Dubrovnik INSPIRE hackathon actually have dedicated one of the challenges, number 10, I think it was, where we are looking into phenology in agriculture and using exactly that, combining optical and SAR data. To get better information, more detailed information about the phenological, the development of, when you sow and when you harvest the crop, to be able to see that with satellite data. So that, if you are interested in that, that will definitely be at the core of that challenge. But as you said, both Jan and Hanka, that there's many application areas for this particular combination. Okay, Elias, Jan, did you use level 1C or level 2A data? And did you use the per-train cloud classifier by Sentinel Hub Synergize?
Yeah, so I used L2A data, so the data which on which some atmospheric correction were already performed, because I believe it's a better the results of this input will be better, but I think not all. Well, I think Sentinel-2 has a global coverage, but I think not all the areas are covered with L2A data, and you can try L1C data, of course, in the process. And regarding the classifier, the cloud classifier, yes, I use the pre-trained synergized classifier. But again, you can use your own, or you can write your so-called custom script, which you use on the Sentinel Hub platform to, to achieve different or even better results. If you know better to do with the classifier.
Exactly. So now, by the way, I'm giving you a link to a collection of all the challenges in more deeply described in the chat box, if you can see, so you can consult, because what we are talking about here, I think both Hanka and Jan have been describing several challenges. I have added some. And then we already, and also for the data cubes, there are many different of the challenges that you can apply all these tools. And that brings me to the next question from Mark. What level of programming knowledge do you require to take part in the hackathons? Are there any recommended resources to get a suitable level of knowledge and ability? And first of all, Mark, I will say that this webinars that we are running Now, this is one of them, and we are running several of them. We are trying to introduce some of the concepts, some training, some light training of the tools that we are using, and we will provide more information. I know, for instance, that in NextGeos we had a webinar on a very basic step-by-step QGIS introduction, and I believe we'll cover that in the INSPIRE hackathons earlier as well. So we will provide you with training material and introductory material if the level, depending on the level of technology you have or the knowledge you have. So that's my comment, but I give the floor to you. What do you think? What would be the recommendations?
Yeah, I don't think it's necessary to be a good programmer because we can hear your ideas or your suggestions, and this is also very important for us. So this is not everything about hacking, but yeah, it's also about your ideas, which are very much appreciated.
Yes, and Jan?
Yeah, you see, I've got my personal experience from hackathon as a competitor last year. I wasn't a skilled programmer at that time, and what I had as an advantage was understanding of the data. And I think this is one of the most important things. You don't have to be a good programmer once you have one at least aside and you are a domain expert. So you understand the data, you understand Earth observation, how it works, because really it's not really about programming. I met situations where programmers really didn't understand the data or what to do with them, and you had to tell them what to do, how to do it.
Yes. And Peter, I'll ask you as well. Do you have any experience with hackathons prior or any comments to this?
Sure. Yes, we have done many such things, and that also has led us to establish Jupyter notebooks that help Python programmers in particular. There are further APIs that you could use. I'm just scrolling down and posting a link to the Python or one of the Python notebooks that might be helpful. They show in a nutshell how to get to it, and you will find out that it's really easy and you don't need to do a lot of magic in programming.
No. So just exactly, and you all said it, that you need different types of skills and knowledge. Just having ideas is equally valuable as somebody who is the nitty-gritty, sorry, get your hands dirty on coding. It's the hackathon is actually about solving a challenge, addressing a challenge, and then of course you need all different types of knowledge and skills and your perspectives. I'm so thrilled that you come from so many different parts of the world, because you all have different perspectives and angles when you're trying to address this problem, and that in itself has a value. So I just recommend you jump in and see what it is. You are more than welcome, no matter what level you're on, and we as a group will try to help you if you need some help, and I'm sure you can provide some valuable contributions yourself, no matter what. Okay.
This is even my case, because my background is in geomatics, and I must admit that I am not so good programmer as well. But I give advice to boys, to our artificial intelligence group, which is dedicated to geomatics view.
And may I add that I've just posted another link for those who are not necessarily into Python. You can find an overview of various various clients that are linked on our documentation. So if you want to just use open layers, or if you want to use QGIS or such, then just follow that link.
Excellent. And since we are having you focus on you now, Peter, or you're speaking, there's a question for you about the data cube from Maximilian. To which level the data is processed? about the data cube, to which level the data is processed. For instance, Sentinel 2 to L1C, etc. You read the question yourself to L2A or Sentinel pre-processing steps. Yeah.
Right. So first of all, data cubes require some homogenization. So below level 1C doesn't make sense. Level 1C onwards is good, and that is what we offer. So for example, SAR data, the GRD, for example, and onwards level 2A or more advanced products. So that is what you get. We are actually working on providing data cube views on even more raw data. That is something that is computationally expensive, as we all know, and in particular the ESA safe format is not exactly optimal. So there is more to come, and we add that on the fly. For now, yes, expect something level 1C onwards.
Excellent. And I didn't forget you, Treggy. I see that you have a question also. What are the current emphasis on AL in relation to agriculture?
Maybe.
Yeah.
Isn't it the current emphasis on artificial intelligence or machine learning?
I would guess that.
Yeah. Yeah. So the current emphasis when it comes to agriculture and machine learning are put on boundaries detection and also for land use and land cover classification. So this is the main goal for researchers that are dealing with machine learning and for agricultural purpose.
Yes, I hope that answered your question, Treggy. And then finally, I think we have Michael. How much time, he's asking how much time it takes to learn or switch from classification within commercial software to classification performed by writing code. Well, I guess that will be very individual, but do you have any idea?
Yeah, well, we didn't try to test some commercial software, but when it comes to our test, it took 3 to 4 hours to teach the network.
Right. Okay. To teach the network. Oh, I see. And then Young Jin, he's or she's asking which different two big data box and voxel. Does this give any meaning to you, or is there some spelling mistakes?
So it might address me.
Yeah.
So let me give it a take on it. Now, I just had to Google for that myself, and there are many uses of the word data box, but there is something like databox.com, and maybe this one is addressed. Actually, this has nothing to do with data cubes. This is just a business analytics tool where I can find out whether your advertisements are placed well. So completely different story. Yeah. There are, of course, different tools that do address data cubes in the sense of multidimensional Earth observation spaces, because as I said, this idea of us has sparked off lots of lab prototypes now. And there is a report by Research Data Alliance which compares some dozens of tools so that you can learn about the differences. While we are continuing chatting, I try to dig out the link and I post it.
Yeah, thank you. So we are approaching the end. I think we have passed, well, we are almost 10 minutes over the hour. I'm thrilled that you have asked so many questions, and thank you so much to all the speakers for answering them so swiftly. Also, I have now in the chat box, you see a link to a collection of all the challenges in both the Dubrovnik INSPIRE hackathon and the Kampala INSPIRE hackathon. The tools, I think it became clear during this webinar that the tools that you learned about today and the approaches that you learned about today in this webinar can be applied on many of these challenges. So you can basically pick and choose what challenge you think is the most interesting for you and relevant for you. and then you can participate in several of these challenges as well. A last word on how. So you find in those two links that I pasted in the chat box, you will see at the end of each of the description of the challenges, you will see a button where you can register to join the challenge. So this is very easy for you to join this INSPIRE hackathon. You can just click that button, submit your name, and then the mentors will be communicating with you. And you will get, you will get access to the workspace. You will be included in a Skype chat channel that is established for each of the challenges. And here is something I really would like to encourage you to, an extra motivation, I believe, for many of you, is that when you are participating in this hackathon, you will not get a lot of money out of it because we don't have any rewards at the end. We do have a final session where we present the result. But what's in it for you is that while you are doing this work, you are also recording everything you do, all the ideas, and you will do a reporting in the middle, and then you have the final presentation. When you are doing this reporting, you are preparing a document that you can publish, so you can use it depending on how deep you go, but it's a great possibility to use this hackathon to prepare a scientific publication if you're a student, that or even if you're a professional, an academic professional, you know that having publications is really important. So you can use this opportunity to prepare a scientific or technical publication. You can also write a lighter version of the work that you're doing in this hackathon and publish to create awareness around what you are doing. So there's many outputs that you can get out of participating in this hackathon, aside for joining this wonderful unit and inspiring community of experts around with all ages and different backgrounds. So there's many benefits, and you will, if you attend consistently, you will also get a certificate for having participated in the hackathon. So there's that. Yes, is there anything else I have forgotten to say, Anka and Jan, that we would like to
yeah,
say?
I think that everything was said, and I want to encourage you that if you are interested in this topic, do not hesitate to join us in our Dubrovnik and Kampala hackathon.
No, and yeah, and I have to say this, Peter, because I know you have been working in this field for ages. I have seen you many times in the community conferences and so on, and giving presentation of the data cube. And for you, if you haven't met Peter yet, he's really giving us a great offer here to help us and help you use the data cube. This is really, really great. So thank you, Peter, in particular, because this is awesome, and you should know it. The attendees should really know that this is great.
My pleasure, and thank you for your kind words.
Okay. Any final words that you want to say before we say hello, goodbye? No. I'll say there will be several webinars in this hackathon. So follow Plan for All on Twitter, because that's for sure where we will publish the concrete links to where you can attend the webinars. And planforall.eu also has a lot of the information. So follow us on social media and keep an eye on the website, and you will see that there are several webinars coming up. We are already one tomorrow. I just want to plug that. We have one webinar tomorrow about the legal issues and ethical issues. I mean, making data interoperable and usable also has this dimension that is non-technical, and that we will address tomorrow. And on Friday, we will address a very interesting and dramatic challenge, namely the locust. You know, the locust is We have had locust swarms in Africa that is devastating for the food production, and this will be covered, and how we can use our tools, the technical tools and Earth observations to help solve that problem. That will be on Friday. And on the next week, we will have several webinars related to citizen science, and there will be more. I don't know everything yet, but there is a whole program next week as well. Yes, so thank you very much. And until the next time, good luck with the hackathon. Bye-bye.
Happy hacking.
Thank you. Bye-bye.
Happy hacking, yes.